Let's calculate some horizontal and slant asymptotes. So first we should look at the degrees, and because they have the same degree, we can just say that we divide the coefficients and that will give us our horizontal asymptote. So y equals 2 is our horizontal asymptote. I don't believe that you're ever going to find something that has a horizontal asymptote and a slant asymptote, or multiple horizontal asymptotes that's a rational function. I could be wrong, but I don't believe that's possible. So the long way of doing this, if you're not sure, is to do out the entire division. And how many times does this go in? Well, it goes in 2 times. So we get 2x cubed plus 12x squared plus 16x. I'm doing 2 times the denominator. And then when we subtract, we get negative 2x squared minus 8x plus 0. But at this point, anything that we do will be all in the remainder. So that's why we got 2 is the horizontal asymptote. Let's do it with this one. Okay, so here the denominator has the higher degree. Therefore, y equals 0 is the horizontal asymptote. But if you need to be convinced, try doing negative 4x plus 8 divided by something with a higher degree. You try dividing this in, and you can't fit anything in. So this is all remainder. Therefore, what did you have as your quotient? 0 was all the quotient was, so that's why it's a horizontal asymptote of y equals 0. Now when we do this one, this problem actually has a slant asymptote because the higher degree is in the numerator. So let's actually do out the division. We can't just shortcut it. So x squared plus 0x, people forget that, minus 16. And then we have 2x minus 2. If we divide this in, this goes in, let's see, 1/2 times 1/2 x times this will give us x squared minus 1x. And then we want to subtract that. So we get 1x minus 16. This goes in 1/2 times. So then we get 1x minus 1. Switch the signs. We get negative 15 as our remainder. And that is our slant asymptote. So the slant asymptote, there is no horizontal asymptote, is y equals 1/2 x plus 1/2. So there's our example of the denominator being larger means that it's a horizontal asymptote. When they are equal, you should be dividing the coefficients, and that last case was a case where we had a slant asymptote because the numerator had the higher degree, x squared over x to the first. Thanks.